Well, thank you for coming to our Databricks user group on data warehousing. So you know Asif, you've met myself. I'm Tyler, I'm a software engineer at Xorbix, and then right behind you is Andrew. He's a data scientist at Xorbix. And today we're going to be walking through an introduction to our data set, which kind of all of our different demos are using. Andrew's going to go through data warehousing tools and using BI tools within Databricks. And at the end, I'll come back and I'm going to talk about Databricks Genie, a new preview feature. So this is today's data set. There's a QR code if you're interested in actually downloading it later on. It's a retail banking for credit decisioning data set. There's a couple, these are just the raw data sources, so where all their data is coming from. And there's lots of pipelines in place within this demo that clean it all up, bring it together. But it's coming, there's internal banking data, there's credit bureau data, there's partner data from telecommunication companies, and fund transfers. So it's all built together to build profiles on different customers and their usage of their different banking institutions. And that's a brief introduction of the data set. I'm going to pass it off to Andrew, and he's going to talk about some data warehousing tools.
Hi, I'm Andrew. So I'm going to talk about data warehousing in Databricks. Today, data and analytics are used more than ever before to monitor operational and financial health of businesses, provide analytical insights for decision makers, and automate time-consuming tasks to be more efficient. And at the center of all of this data work is data warehousing. I want to explain a bit about why data warehousing is important, and that starts with it being a centralized system. So what I mean by that is all users of an organization benefit from having organized data that is consistent across all teams and is useful data. Warehouses are optimized for analytics, so specifically things like running complex queries or table aggregations. And then they also store both current and historical data. So different possibilities like trend analysis, forecasting, and reporting exist for these different time periods we have stored. Data warehousing supports business intelligence and machine learning. So as we go through the presentation and learn a little bit about Databricks Lakehouse, we'll see where at different times warehousing is used for both BI and ML at different stages, and especially in today's climate where more and more ML is coming into play for a variety of use cases, it's important to understand how often it really is used. Data governance and quality control help enforce not only data security and compliance, but also correctness and responsible use of data. And then particularly modern data warehouses have a big focus on scalability and flexibility. So we'll get into a little some of the traditional challenges that were had with data warehousing. But today there's so much data out there and it's very diverse. And so a focus for data warehousing is to be able to work with all of that data. So quickly, I want to talk about the differences between data lakes and data warehouses. So data lakes take in raw data. There's no processing done necessarily, and it can come in really without a defined structure or schema. So we have unstructured, semi-structured, or structured data that has not yet been processed. On the other hand, a data warehouse holds structured data, and this typically will come from a data lake after being processed and moved out of the data lake into the warehouse. So the challenges with traditional data lakes and data warehouses, for data lakes, a lot of the issue comes with governance because of the lack of structure in a data lake. Since these data sets are not easily defined, it's hard to govern over that type of data. Data lakes can be inconsistent, again, because they don't enforce any kind of structure or schema. And then data lakes at scale struggle with performance compared to warehouses. So data lakes can hold tons of data and often do hold more than a warehouse, but the speed at which data can move from a data lake is not the same as a warehouse. And then for data warehouses, they are typically more costly than data lakes, and they're also inflexible. So either one of these on their own have these issues, but they can work together to create a full process for data warehousing. And I want to talk about Databricks Lakehouse and its underlying technology called Delta Lake. So the Lakehouse is a solution to isolated data silos. So the individual silos would be the lake and the warehouse, but a lakehouse combines the two and keeps everything under one roof. Some of the main benefits are cost efficiency, not having to maintain multiple data lakes and warehouses, but have it all in one. And then because these are all under one roof, it's easier to optimize and scale for performance and be flexible with your data. Okay, so this is a Delta Lake pipeline. So the main technology that Databricks uses in a lakehouse is Delta Lake, and it operates on the medallion architecture. So as we work our way through the pipeline of this Delta Lake, we're improving data quality and have three distinct layers. So we have the bronze layer, the silver layer, and the gold layer. Now, if you picture kind of the data lake and the data warehouse being separate, try and imagine where you would find in here what a data lake is and a data warehouse. So the bronze layer is somewhat of a landing zone for raw data. So this is where it's somewhat like a data lake. It accepts all kinds of data, whether that's batch or streaming, and this layer does not have a defined structure. It can be unstructured if it happens to be. At these different layers, there are different tasks that can be performed. So as we go along, there will be an improvement in data quality, but that doesn't mean we can't do anything with the raw data in the bronze table. So some machine learning cases specifically that require real-time analysis and streaming machine learning models, they sometimes need access to data very quickly and need to be able to make a decision quickly. So things like real-time pricing and fraud detection or other anomaly detection methods can use this data in the bronze layer. As we improve the quality of the data for the silver table, go through the process of filtering and cleaning the data and usually enriching it in some way with feature engineering or some new data. And at this point, we define a structure and enforce a schema. So we're already getting into the warehouse territory at this point. And here, again, a lot of the tasks are going to be ML based, and data scientists often use this layer for feature engineering off of what's already given in the silver table, and it can still be done in near real time. So it's not necessarily streaming, but it's close to real time and has much higher quality than the bronze layer. At this level, some of the tasks that are done in machine learning are things like predictive maintenance and customer behavioral analysis. And then lastly, the gold layer is our business level aggregate data. So this is ready to use data for business intelligence, easily visualized in dashboards or single visualizations. And for machine learning, this is where you would take the highest quality data for the most important models that require highly accurate data and don't need to be done immediately, like any kind of real-time analysis. So things like time series forecasting, where a model can be sensitive to change, or the gold layer will have data for you there that is the highest quality. So this entire pipeline is going to be your lakehouse. Really, whichever way you decide to implement it, you could just, depending on what kind of data you put in it, you could just really have silver and gold if you already have cleaned data that you're importing. Okay, and then so as Tyler was just saying, something that's a big benefit when you have all of this data warehousing under one roof is that you can have end-to-end security, and this happens through Delta Lake at the pipeline steps, and then Unity Catalog when you're working across workspaces. So any kind of management of which groups can handle which kinds of data, that can all be done, and enforcing schemas so that poor data doesn't get into your tables is also something done with Delta Lake. And it's really just a goal of ensuring reliable data is being used by the correct people and that it doesn't get screwed up somewhere along the way. So for Databricks SQL, you can query directly on the lakehouse. So these are optimized high-performance queries and allow for collaboration. I'll go into a little bit on data visualization in the platform using their dashboards, but it's pretty cool to be able to collaborate and have SQL right inside your environment where you are also coding and using the data. So then the dashboards for data visualization. This is just a little bit of general use for data visualization, turning data into actionable insights, specifically stuff that can be used by non-technical people to understand what the data is really talking about and to make decisions based off of those findings. Dashboards are great for real-time monitoring and, again, decision making, especially in modern settings where you can have live tables. It's easy to monitor really any kind of data. And then dashboards simplify data exploration. So for Power BI and Tableau, these are really easy to use tools for someone who maybe doesn't know how to build a visualization in Python or R. And these are, once again, collaborative in Databricks. So the internal versus external visualization tools for Databricks, the tools that Databricks offers are what I'll call simple but viable. A big pro for Databricks is that they're easily shareable. And if you're all working in Databricks, you don't have other premium memberships for programs like Power BI or Tableau. But then external tools, you have far more options. Power BI and Tableau are a lot more powerful than what Databricks dashboards can do, or even their in-notebook visualizations. But they do have just enough where you can make some great dashboards in Databricks, or you can connect to the external tools from Databricks, which I'll show. But yeah, with Power BI, Tableau, you have the ability to create more complex visualizations, but they typically come with an added cost. So these are Databricks dashboards. Essentially, you have your canvas and data, and this behind the scenes is just Databricks SQL. So it's pretty cool that you can have your SQL code, I guess, so close to your actual dashboard. When you use something like Power BI, I guess you can write a lot of that stuff in, I think DAX is their behind the scenes, making calculated fields with DAX and whatever. But I think SQL is generally more easily understood. So each of these different tables are used here. So essentially, if I want to look at this table, it was created in this data tab, and I can kind of show you right here. These are the options for your visualizations. So from area down to table, there aren't many, but I would argue that bar charts, line graphs, and scatter plots are probably some of the most important visualization methods. And so I think that it is viable to use something like this for a lot of dashboards. It's just not, it's never going to, well, maybe someday it will, get to a true BI tools level.
All right, so I am going to talk about Databricks Genie now, which is a new tool from the Databricks platform. It's currently in preview at the moment, or public preview. But before I even get into what Databricks Genie is, I just kind of want to highlight what its purpose is, why it was created in the first place. So the idea here is to democratize data, basically allow anybody from any point of the company to be able to get new analytics, find information, get insights quickly, especially non-technical users. So how this is done through Genie is essentially a question answering natural language powered chatbot. You ask it a question, it generates SQL and graphs with just a single prompt. So you can ask it essentially just like, show me bucket by marital status, the average salary or something like that. It'll generate that table for you, and then you can ask it to visualize it, make a bar chart, pie chart, whatever you feel like. Some of the nice features of this is, since it's part of Databricks, you get all the benefits of the Databricks ecosystem, so Unity catalog, and then some features specific to this one are it has a continuous learning and response rating system. So as users are using the system, hey, this chart was awesome, they can give it a thumbs up, and then you can look at that later in this nice audit log. So then, as I'll talk about in a second, it does require a little bit of setup, but those developers who set it up can then see, okay, we need to tune it this way so it gets these prompts better. We need to change this thing and that thing to make sure it runs a little better. Some use cases for this, and these are just directly from Databricks. A sales manager wants to get the current status of an open and close opportunities by stage in their sales pipeline. They can interact with the Genie space using natural language and automatically generate a visualization. So as you're seeing here, it's this quick like 10-second demo they have on the right, but he asked it essentially this question. He asked it, what stage are my open opportunities as of today? It hits the database, generates a query, gets a table, and then he asks it to make a bar chart. And boom, 10 seconds, he has that info he needs, he's good to go. He has his data. Here's another use case provided by Databricks. A logistic company wants to use Genie Spaces to help business users from different departments track operational and financial details. They set up a Genie Space for their shipment facility managers to track shipments, and another for their financial executives to understand their financial health. So I wanted to include this one. There isn't a nice fun demo with this one, but this one's showing kind of the separation of domains. So you're going to have a billion tables, that's exaggeration, but you're going to have a ton of different data and that data is only going to be specific to certain departments. So the shipment facility is only going to need to look at ingoing and outgoing stuff, and financial health needs to see all the numbers, all the data, how many sales are being made. So one thing that's important, which we'll talk about in a second when setting up a Genie, is that separation of domains to avoid confusing the AI models that are running in the background. So this is going to be a little aside, just kind of how it works in the background. So there's kind of two components. There's one component that you can't really control, which is essentially the tool provided by Databricks. So their actual compound AI system that's running in the background. They don't provide too many details besides some very vague statements on how this is actually operating and run, but I've tried my best to find as much information as I could. The other portion is what you as like a developer has control of. So this is, I'll talk about it in a second. You can provide it instructions, a lot of prompt engineering, you can provide it example prompts, and there's a couple other tools you can use to help control its understanding of the data it's looking at and to help guide it to the correct answers when a user queries it. So talk more about what a compound AI system is. When you're talking to just a large language model in general, it's just a single model. It's basically a black box. So it's just a whole bunch of numbers being multiplied together, and it generates some kind of answer. But you don't really know why it's generating those answers in between. A compound AI system, on the other hand, combines both large language models, small language models, and classical software engineering tools. So this demo would just kind of have some random icons, but you can have a Python executor, you can have a SQL database it talks to, maybe some kind of retrieval system, and those all kind of work together somebody designed a whole system, so all those elements can interact together and perform better than a single model alone. And I kind of just mentioned some of these, but the big benefit here is through improving the AI outputs through system design rather than static training, especially since most systems these days usually use some kind of proprietary model that's only updated every 9 or so months. So this helps improve results a lot, and it's more easy to adapt the models to different kind of goals. So instead of just throwing the same model at every single problem, now with system design, you can be, okay, this one needs to talk to some kind of retrieval system. This one needs to execute Python code. So you can design it more to specific requirements. So some other examples of compound AI. So the Genie, which I'm showing, is a compound AI system. Some other general ones, one I'm very familiar with is retrieval augmented generation, LLM. Simple system. You have a large language model talking to some kind of retrieval system to get more updated info rather than just relying on the bot alone. That's like kind of the simplest compound AI solution. LLM interacting with some other system. ChatGPT is another one. That when I say ChatGPT here, I mean specifically their web application, not like GPT 3.5 as Asif brought up. So that one, when you interact with it, there's a whole bunch of tools happening in the background. So if you ask it to search for something, it's going to hit Bing, get results, have an informed response based on Bing. Ask it to generate an image. It's not the large language model that's generating the image. Now it's talking to DALL-E to generate the image and send it back to you. And then there's a whole bunch of other extensions that do a lot of fun stuff, like a Python code processor. All right, so now back to the Genie space. It's currently in public preview, so if you need to go through your admin settings and click a little button to turn it on. It's off by default. Some other requirements, your data must be part of Unique Catalog, which at this point in time, almost everybody's data on Databricks is part of Unique Catalog. You also need a SQL warehouse to run the Genie, and that needs to be either a serverless tier or a pro tier. And then a small note, a Genie space can only hold a maximum of 25 tables. So that kind of comes back to the idea of, domain separation, because, okay, they only need to see 5 tables instead of all our 50 tables that we have in our pipeline. But yeah, back to the data that it should use. So clean data, I generally recommend, like Andrew's talking about the different tiers of data. earlier. So we have the bronze, silver, gold. Silver data I would recommend here mostly because then it can form new aggregates. Unless you're making a really specific Genie and you wanted to use the gold data, but generally silver, so then it can make those new associations and build new connections, because generally the gold layer is going to be pre-built for those aggregates, so it's not really going to be able to extract or make too many new connections. So I talked about all of that. So just some general tips for, there's an instruction section you can make. So this, you want to put like any company specific info, your fiscal year, any important dates at your company, any like common SQL rules you want it to follow while it's generating. So example here is, use abbreviations for states. So then every time it generates some graph with states, you're telling it, okay, use the WI instead of Wisconsin. And then another one that's more specific, which I pulled out from Databricks documentation, is you can create like special functions within SQL, user-defined functions from Spark too. You can make those work. So if you have like a special function here, like get quarter to convert a date into quarter one, quarter two, you can just tell it to do that, and it should hopefully follow it. That's kind of the goal. So provide it instructions to get to your specific answers. Then the other portion you can manipulate is the example SQL queries. So this is, just a plain simple SQL query that can be anything with a description of what this query is for, what it's getting out. Description can be anything. It's just kind of helping inform the model why this is being used, when it should be used. Some nice features with these are, one of them is you can add what are called SQL parameters. So this is telling the model, okay, when we see the colon example parameter in here, that means that this is something you're allowed to replace in this query. So if you see something that matches, maybe we want to see the average marital status. I'm back on that topic. The average revenue of different marital statuses. Maybe the example parameter can be which gender or which, I don't know, ethnicity, whatever's in your table. So then you can tell it, okay, we only want to see this type, and it can replace that for you in like a where clause or something like that. Another cool feature is what's called trusted assets, and this is more a benefit for the users of the system. So these are predefined SQL queries that if the model matches up with and replies with that exact same query, there'll be a little badge in the corner of the chat that says this is a trusted asset, which is basically telling the user a human actually made this query that's being ran right now rather than it being AI generated. All right, so are there any questions so far? I'm going to hop over to kind of just show off actually what it looks like in Databricks. So you first come in, you have it enabled, you have a Genie little button in your SQL area. And then let's say you want to create a new Genie space. It's pretty simple, straightforward. Title, description, warehouse, so it knows where to throw your compute at, which of course mine is stopped right now. But then all you do is you select which tables you want to include it in. So we have our DB demos, that's where we store our demo data in this schema, which is the current demo database. And then we get a list of all the tables. So let's say I want customer silver, pops it into the list below. I select account silver, pops into the list below. So this is just the initial setup. You're like, all right, here are the tables that you have. And you can also set up sample questions, which this is another feature for the people who are using the system. So you can have little bubbles that like, oh, here's a good query you can use to find some information rather than just giving them an empty chat box. But the sample questions won't affect how the model is actually creating final results. All right, yeah, so it's really simple to set up. Here's your tables, here's your name, go crazy. Here, I'll start my warehouse, and I'll talk about the tabs again. So yeah, chat room, instructions. Here I just threw it some basic rules, which if it'll let me scroll down a little bit more, there we go. I have some basic rules, and then up here I just have a big copy and pasted description of all the different data that's available from our data sets. And then I have some basic rules in here, like months should always be the name of the month. Use the date form, use this function here when converting the date to a name. There's a specific function within Databricks SQL you can use to convert a date to whatever named date that you want. And then I also put date should always be ordered for the month number, not the text of the month name. Because as I was testing, I found an issue where when I would have a graph of month names, it would order them alphabetically. So April always came first, and then it didn't look right. So this is one of those things where you need somebody who knows the data and plays around with it to kind of tune the system so that, when, a C-suite person comes in and wants some kind of new thing that, nobody's made a query for before, it at least will work. They can type in a question and it'll show up. Then we have, your example queries here. So show me the distribution of customers by income brackets as a bar chart, and then I just have a query here, which the bar chart doesn't really apply because this is just a query, but this is the SQL to generate it. And then here's that parameter feature I talked about. So you can add the name, add parameter, and then you have a parameter so that tells the system, okay, you can replace this part of the query. Okay. And then the final part is the trusted assets, which these need to be actually created. They use SQL functions instead of just giving it a query, which is a little annoying. So you have to go to a workbook or open a query editor, make a SQL function. But then once you have a SQL function, then you can pull it in here. And that's all you do in this spot. You don't give it a description or anything. You're just here's a SQL function we've already created. And then if the AI system decides that the results of that one will line up with what you're looking for, then you get the trusted asset little icon. Some of those other features, you can explore the data here too, which, if somebody familiar to Databricks knows how to do this. So this is meant for somebody who isn't a data engineer. So this will just show them, here's your tables that you have. And then, if you have descriptions or comments, they'll pop up here. So this is more for people who really don't know the data. So you want someone to go in, add all those descriptions so that, C-suite person can be like, oh, that's why this is named this, or that's why we're pulling this data in here. This monitoring tab, goes back to the rating response auditing feature. So, as a developer person, a person not actually using the system but making it, I had this visualization which somebody labeled as bad, and that was because the 100K is at the beginning, 100K plus instead of the end. It doesn't really follow the order of the rest of the numbers. So that would be something a developer would have to go in and go, okay, that was not a good query. I need to go add an instruction so it doesn't do that again. But going to the part of actually using this system now, it isn't turned on, so I will show you some of my previous chats. So you can ask it just general questions about your data too, which this does not like to be zoomed in very much. But I asked it, there's a button here if I go to a new chat that's explain the data set. That will throw in the question, what tables are there and how are they connected? Give me a short summary. So it'll look at all your tables. This is where it's going to look at those descriptions that you've put into Databricks for each column, each table, and it's going to make some inferences. So I didn't even have any descriptions or comments at all, but it was able to infer a lot of things just based off the schemas and the tables provided. So account silver contains account-related information for customers, including the number of accounts, average balance, and operation type. It's likely connected to the customer field through the cust_ID field. So even though it didn't have that description, it was able to infer that, okay, your customer table has an ID column, and this table has a customer ID column, so it probably means these two are connected together. So you're able to ask it questions like this, and it would be a lot more informative if you had all those descriptions in place already, because it would just pull from those and give you a response. So some other query. Okay, so it's actually running now. So let me show you this running live. Let me close this. I have a few example queries I'm just going to grab. All right, so let's ask it the distribution of customers by income bracket. And I'll throw that in here. And the first thing it always does is it's always going to generate SQL first. The one kind of thing I find annoying about this is it won't do a SQL execution and a visualization in the same query. It always does, okay, here's the data, and then you ask it to visualize it. And the other nice thing is it always has a little natural language response with all of its queries. So query provides, it's telling me this provides a distribution of customers by income, categorizes customers based on their annual income, and counts the number of customers. It's really repeating itself here, but at least it'll inform you of okay, this is what I'm trying to do. This is why I made the query. So yeah, here we go. Here's that data that I just asked it for. So here's those different brackets, different customer counts. Some nice things here. So here's those review buttons. I'll go, okay, this is good. This is what I was looking for. Rate it. Now it's in that audit log showing it's a thumbs up. This button I like a lot. So this is add as instruction. So if the AI generates an awesome SQL query and you're I want this to influence everything else that's going to be made, you can just click this button and it'll just add it right to your example queries that you have. So then you don't need to so that eliminates some of that need of like a developer sitting down and putting in all these queries. You can just query it. All right, that's a good one. Add it to its knowledge, and it's good to go. Another thing I like is, okay, let's say it gets 90% of the way there. Let's say you're an actual data engineer. You can actually modify the SQL it generates in place and then just rerun it. And then you can continue the conversation off of your manual edits. And then, maybe you can do that and then hit add as instruction after you fixed it. So yeah, I got the data back. Now, it'll give you some quick actions being like, oh, do you want to do these? I like that there's an auto visualize feature. So this is just telling the model, okay, you figure out what's the best way to lay out this data. And I've noticed, I think it really likes bar charts. I think the model really likes bar charts. But yeah, let me see if I ask it. Let's see, show me this as a pie chart. Let's see what this does. And going back to like the conversational aspect of this, it's easy to just ask it these kind of cumulative questions of like, okay, based on what happened before, do this new thing, because it has all the reference to your previous chat. So now here's a nice little pie chart, and most of the groups are equal. So, and oh, this chart's actually a little nicer. It's got a little tooltip and stuff. Cool. But let me throw in another query quick. So the total transaction amount by currency grouped by month. So let me copy that, paste that in here. And we're going to go through that same process. So it's going to generate the SQL output. It's going to think for a second. I'm not paying for the $1 million tier of this, so it takes a little more than that demo I showed earlier. And then after a little bit, so even while it's generating, I can see what code it used. So there's that date format coming in, and that's coming because I told it to in the instructions. And it's also pulling out the month value too. So here we go. We got all our months, and we got our total transaction amounts, and the only currency that's being used is USD, so there's no other groups in here. Now let's visualize this again. Let's do a line chart. And let's see how this turns out. I have a feeling it's going to organize them alphabetically or do nothing. Interesting. So this is a bad response. I'm going to rate it a bad response. Let's see, visualize as a bar chart. I have a feeling the reason the line chart didn't work is I bet it was trying to use the month name, and it was able to convert those to a numerical value. So here we go. Here's the issue. April, December, June, May, October. So it's doing alphabetical order. So let me do some iterative ask. Let me order the months by month number instead. So now it's processing a new query, and hopefully, if it listens to me, it should go from January to December. It did listen to me, but it didn't want to use the month names. It just used the month number directly. So that's like another thing that comes to training. Sometimes it takes you a little too literally because it's not a human. It's a robot trying to figure out what you want. So here, it did what I asked it to. It used the month number instead, but in the chart, I would rather it be the month name. But yeah. And then the last query I wanted to show is just showing what it looks like when you hit one of the trusted assets. So I have bucket, the average total revenue of customers by their marital status, and that's why that example was on my mind all afternoon. And as you can see, it went, oh, we found a function that matches your question. Here's a little badge that says this is made by a human. And then you can go through the same process, make a visualization, get your data out, modify the data a little bit if you want to, you can do all your iterative stuff. But yeah, the real power of this is like, okay, your boss wants to find new ways to look at your data. You can build this for them. They can walk in, they can ask their questions here instead of spending 3 hours trying to make a SQL query to get the data they want. They can ask this system instead. So that's kind of where the benefit is here. So there's like definitely the benefit of new engineers learning the system. There's the benefit of non-technical people getting insights without having to ask technical people. So the idea here is to alleviate a lot of that manual, tedious kind of work and have an AI do it instead. And this is still in preview, so as you see, there's little weird quirks here and there that hopefully will be worked out over time by the time this gets fully released. But it's a really nifty feature, and using actual data, you would probably see a little more interesting things than this demo data set where almost every single month is equal. But yeah, this was Databricks Genie. It's a cool new feature, so I wanted to show it off a little bit. But I think that just about wraps everything up for today.